Today we're going to multiply fractions. And let's go over a couple of very important steps. There's two things you need to keep in mind. First of all, first most important step is to change any mixed numbers into fractions. Change mixed numbers to fractions. So for example, if I have 2 and 2/5, this is a mixed number. Change mixed numbers to fractions. So to change that, keep the denominator the same, but remember we want a times plus. Times plus. 5 times 2 is 10, plus 2 is 12. So this is what we mean by changing mixed numbers to fractions. Another important step is to reduce before multiplying. Reduce before multiplying. So for example, I have two fractions and I start to reduce it. Well, let's see, I know that 11 goes into 33. 11 will go into 11 once, and then it goes into 33 3 times. So now that's a 1 and that's a 3. And also 6 goes into 12. 6 goes into 6 once, 6 goes into 12 twice. So I reduced everything, and now I just go ahead and multiply. 1 times 1 is 1, and on the bottom 2 times 3 is 6. See that? We reduced before we multiplied. Otherwise we'd have 66 over some big huge number. Okay, we'll do 9 examples. So we have number 1, 1/2 times 5 over 7th. And is there anything to they're already into fractions. There's nothing to reduce. I can't do 2 and a 5, 7 and a 1 or anything. So I just multiply straight across. As a matter of fact, it's just like this. I'll write this for those who are still a little having trouble with fractions. So I just 1 times 5 is 5. 2 times 7 is 14. And there's our answer. So if everything's all reduced, just multiply straight across. Now if you notice on the second problem, I'm writing it twice because I'm going to rearrange, I'm going to be making some changes on here, and if you look back on it, you're not going to know what the original problem was. So that's why I'm writing it twice. Now if you're using different colors, then that's no problem at all. Then you probably don't need to. So 5 over 27 times 9 over 25. So first I like to see what I can reduce. Let's see, I know 5 goes into 25. 5 goes in there once. See, that's my original problem. I'm going to leave that alone. 5 goes into 25 5 times. So now this is a 5. And that's a 1. 9 and 27. 9 goes into 27. 9 goes into 9 once. And 9 goes into 27 3 times. So see, now I've reduced everything. And now I multiply straight across. 1 times 1 is 1. And 3 times 5 is 15. See, now you can look at the original problem and then see what changes you made to it. Just to let you know, I'm writing fairly small. Here's the bottom of my paper. Just give you some idea. So 3/6 times 4/5. So here's my original problem. I'm going to rewrite it down below here. And now I'll start reducing. Notice right away that 3/6, that can be reduced. Okay? Because 3 goes into both of those. 3 goes in here once, and 3 goes in here twice. Now here's where it gets a little tricky. Notice that 2 will go into 4, because this is now a 2. It's not a 6 anymore, it's a 2. 2 will go into 4. Watch this. 2 will go into 2 once, and 2 goes into 4 twice. So see that I reduced like a couple of times. You could do that. You're allowed to do that. All right, on the top, I have 1 times 2, that's 2. And on the bottom, 1 times 5, that's 5. Now we have a whole number this time, 12 times 3/10. Okay, so there's our original problem. Now let's do some changes to it. First of all, notice that this is like having a 1 under it. Okay, so the invisible 1 is sitting down there. And let's see if I can reduce it. Well, look, 12 and 10, 2 will go into both of these. Matter of fact, so 2 goes into 10 5 times, and 2 goes into 12 6. So that's going to give, and that's all I can do. 6 times 3 is 18. And 1 times 5 is 5. And if you end up with an improper fraction, go ahead and make it a mixed number. How do we do that? Let's see, 5 goes into 18 how many times? 5 goes into 18 3 times. That would be 15. 5 times 3 is 15, and 3 more makes 18. So 5 goes into 18 3 times with 3 left over. Okay, on my notes, I'm going to go up to the top of the page now. Okay, now this one, we have 4.5 times 12. We have a mixed number times a whole number. Now remember, we said mixed numbers. We need to change any mixed numbers. Change mixed numbers to fractions, like so. Okay, so that's what we're going to have to do here. So I'll just put it underneath. Denominator's 2. 2 times 4 is 8, plus 1 makes 9. So this is the same thing as 9 halves, times 12, and we'll just put a 1 under that. So now we have fractions. And we can reduce, because we have 2 goes into 12, 2 goes in there once, 2 goes into 12 6 times, and that's it. So what do we have? On top we have 9 times 6, it's 54, and on the bottom 1 times 1. So it's just 54. 54 is our answer. Number 6, we have 1/3 times 1.5. All right, so we have 1/3. And 1.5, that can be changed to a fraction. 2 times 1 is 2, plus 1 is 3. 3 halves. Okay, so now I reduce, and 3 will go into 3. 3 goes in there once, 3 goes into 3 once. So what do I have left? I have on top 1 times 1, that's 1. On the bottom, 1 times 2. So we have 2 mixed numbers, 1 and 1 6 times 4.5. So we need to change those to improper. Denominator stays the same. So we have 6 times plus. Times 1 is 6, plus 1 makes 7. Times plus. 2 times 4 is 8, plus 1 is 9. Okay, so now we can start reducing, if there's anything. Let's see, 2 and 7, no, but 6 and 9, 3 will go into both of those. 3 goes into 6 twice. 3 goes into 9 3 times. See, that 3 went into both of those, 2 times and 3 times. So now I multiply 7 times 3, that's 21, and 2 times 2 is 4. So we have a fraction, but we cannot leave our answer as an improper fraction. So let's see, 4 goes into 21 5 times, right? Because 4 times 5 is 20, and there's 1 left over. So put that left over right up there. And there's your answer. Number 8, we have two mixed numbers. We need to change those to fractions, actually to improper fractions. So let's see. 5 times 2 is 10. 10 plus 2 is 12. See? Times plus. And then this one, times plus. 3 times 1 is 3, plus 2 is, see, 3, 4, 5. Okay, so now I can start reducing, now that we made them into fractions. And 5 will go into 5. 5 goes in here once, and it goes in here once. 3 does go into 12. 3 goes in here once, and 3 goes in here 4 times. So what are we left with? We have 4 times 1, that's 4. And on the bottom, 1 times 1 is 1. So our answer is just 4. Here's the last problem. Now there's a lot of reducing that you can do in this. So 9 over 2, 4 over 3, 5 over 6, 8 over 20. Okay, so let's look through here. I have 2 going into 4. 2 goes in here once, 2 goes into 4 twice. I have 3 going into 6. 3 goes in here once, and 3 goes into, 3 into 9. 3 goes in here once, and 3 goes into 9 3 times. Okay, what else we have? We have 5 and 20. So 5 will go in here once, and 5 goes into 20 4 times. We have 4 into 8. 4 goes in here once, and 4 goes into 8 twice. All right, what else we have? Hey, look, I have 3 and 6. 3 and 6. 3 goes into 3 once, and 3 goes into 6 twice. So what's left? I have a 2 on top, and a 2 on the bottom. So we can just reduce those, and it doesn't matter which 2 you go with, but 2 will go in here once, and 2 go, you can choose any one, and 2 goes in here once. So what do I have left? 1, 1, 1, and 1. 1, 1, 1, and 2. Looks like I'm pretty much done. If I multiply the top, 1 times 1 times 1 times 2. 1 on the bottom, 1 times 1 times 1 times 1. So our answer is just 2.